So let's review before we get started. We're going to review decimals to percents, percents to decimals. Back in 7th grade, I remember teaching this as DP, decimal to percent. If you're going from a decimal to a percent, you move right. So write rates as percents, you're going to move the decimal right 2 places. DP, decimal to percent. If we're going from decimal to percent, we move 2 places to the percent. So if I have a rate of 0.07, I'm going to move it over 2 places. And that gives me 7%. $14, there's no decimal. Well, there is. There's an invisible one at the end. So you move it over 2 places again. 1,400%. 1.36%, you move it over 2 places. 136%. If you're going to write a percent as a rate, let's say we start with a percent, we want to go back to a decimal, we're going to go left 2 places. To get it to be a decimal. So if there's not a decimal, it's at the end. We're going to move it 2 places to the left. 1, 2. That gives us 0.6 or 0.60. I really like to have it with 2 decimal places or 2 numbers behind the decimal. 7.2%, you're going to move it over 1, 2. If there's nothing there, you put a 0. So it's 0.072. 145%, put your decimal there. Move it over 2 places. 1, 2, 1.45. So you got to know how to move from decimal to percent, percent to decimal. Exponential functions either increase or decrease as a rate, but we can also write it as a percent. Just like with the Futurama episode, they had an interest of 2.25%. So it increased at that rate. But it was as a percent. All right, let's review exponential parts that we learned yesterday. A is the starting value. It's also called the initial value. It's how much you start with. So 93 cents is how much Fry started with on the Futurama clip yesterday. It also starts at the coordinate pair of 0A, which is the y-intercept. So A is your y-intercept. And then B is your growth or decay factor, and it has an exponent of x. So these are pictures of exponential growth and decay, so you always read them from left to right. Exponential growth depends on what B is. If B is greater than 0, then it is growth. It's going to look like this. But if B is between 0 and 1, it's going to be decay. And the way you see that as an inequality is 0 is less than B is less than 1. That's a compound inequality. So we're going to look at some equations. We're going to write some equations based on the A and B. Go ahead and open up your notes. So I wrote the equation again here. A times B to the A. Growth or decay depends on what your B value is. The initial value is A. Your growth or decay factor is found by doing 1 plus or minus the rate. So if you if it's growth, then you add the rate. Make sure you listen. If it's growth, you add the rate to 1. If it's decay, you're going to subtract the rate from 1. So that's why it has plus or minus, because look at this, 1 plus R, and this decay is 1 minus R. All right, let's look at our first one. Y equals 5, parentheses 3.6 raised to the x. So growth or decay depends on your B. Your B is at 3.6. It's greater than 1. So this is growth. So it's B equals 1 plus the rate. That's the equation we're going to use. Let's write what the initial value is. It's the A value. So A is the first number. So it's 5. The growth or decay factor is B, 3.6. So the growth rate is based on 1 plus the rate. So the rate is found by taking 1 away from it. So what we want to do is we want to do 3.6 minus 1. So if I have 3.6 and I take 1 away, what do I get? Yeah, 2.6. That's the rate that it's increasing by. This is our growth or decay factor. But to find the rate, you always compare back to 1. How far away is 3.6 away from 1? We're going to subtract. So this 3.6 equals 1 plus the rate. 3.6, 1 plus 2.6 to get 3.6. And then the rate as a percentage, we're going to move this to, how do we move from a rate to a percent? To the right, 2 places. So we're going to go 1, 2. So it's a 260% increase. So it more than doubled. 200% increase. Well, it almost tripled. All right, go to the next one. We base our growth or decay on the B value. It's smaller than 1. So that means it's going to be a decay. So the decay one is B is found by doing 1 minus the rate. We know what B is, but we need to know what the rate is. All right, A is the first number. Write it down. B, 0.94. And then our rate is comparing it back to 1. So I want you to find the rate by compare to 1. Like the number 1. How far away is your B from 1? Yeah, 6. So you do 1 minus 0.94. So if you're not sure, always use that calculator. 1 minus 0.94. 0.06 is our rate. That's the rate of decrease. these add up to equal 1. See how they are? So with decay, they'll always add up to equal 1. So we need to create this as a percent, so write it down. To write a rate as a percent, I need to move my decimal over 2 places. So it's 6%. Okay, the next one doesn't give us our equation, but it gives us A and B. We can write our equation. So look at what your A is, look at what your B is. Write your equation according to the equation. So it's y equals A times B to the x. So it'd be 10 times 0.75 raised to the x. So you look at the growth or decay factor, the B. It's smaller than 1. So what is this? It's decay. So it's 0.75. So it's not even the full 1. 1 would be, it wouldn't change the value of 10. But since this is 0.75, it's going to decrease by a value. So that we're going to have B is 1 minus the rate. So from the B, we need to find our rate. You compare it back to 1. How far away is 0.75 from 1? 25. So 1 minus 0.25. Oh, 0.75, sorry. I wrote the answer instead. So 0.25. So it's a decrease by 0.25. So 0.25, write it as a percent. 1, 2, 25% decrease. So it's kind of like a sale at the store. They're saying it's 25% off all shirts. The value would be decreased by 25%, which means that you're actually only paying 75% of the original cost. But together, 75 and 25% make 100%. So that's how decay works. All right, look at the next one. We're given that it's a decay, and we're given the A value. We're asked to find the B value. The B value is found by doing 1 plus or minus R. See how that's up here? So since this is decay, it's going to be B equals 1 minus R. So to find B from our rate, we're going to do 1 minus 0.05. One minus 0.05. 0.95? So that's what the B value is. Remember how I said always compare it back to 1? Comparing it means you're subtracting it from 1. What's the difference between them? All right, now that we know our B value, we can write our equation. Y equals 32 A times B, 0.95, raised to the X. So it's 95% of the original. So it's going to go down each time by 5%. It's going to decrease by 5%, which means it's going to have remaining 95%. Now the percent of the rate, 0.05, write as a percent. 1, 2 places. So it's 5% decrease. So anytime it's decay, it's a decrease. Decrease. Go ahead and write the word decrease on there. Anytime it's decay, it's decrease. This one up here, 6%, it's a decay, so it's a 6% decrease. And then that first one, 260% increase. Imagine your money increasing by 260%. That would be awesome. Okay, we have one last problem. Okay, they've given us A. They've said that it's growth. So B equals 1 plus the rate since it's growth. Okay, we don't have B, we don't have R, but we have the R percentage. So we need to go from percent to decimal. So I'm going to put 30% right here. To go from percent to decimal, I'm going to move it over 1, 2 places. 0.3. Since it said growth over there, this means it's a 30% increase. To find B, we're going to use that 1 plus the rate. The rate is 0.3. So when you add 1 to 0.3, you get 1.3. That's my B value, because you always compare it back to 1. If it's an increase by 1 or by 0.3, then you add it. If it's a decrease, you subtract it from 1. So then our equation is y equals A, 560, times the rate, or the B value, 1.3, raised to the x. You'll glue this in the next page, but you'll keep this out in order to do your assignment.